Okay, what I want to do in this set of videos is I want to look at comparisons kind of between node voltage and mesh current. Really, a lot of times it's going to become obvious that node voltage or mesh current is the easier way to go in a circuit, but not always. So as a way of reviewing node voltage as well as mesh current and providing you with some additional examples, we're just going to look at some of these problems and look at the differences in how the equations set up depending on which method you choose. So we'll start with this circuit here. This is from another book, so that just gives you some additional examples and additional circuit configurations. So we'll start here, and first of all, let's identify the nodes. So we got one here, and then one that's common to the bottom. I'll choose to ground the bottom node because it's connected to the 10-volt source. Let me identify this node as well. So I have V1, V2, V3, and my reference. So from the figure, V1 is 10 volts. And then, and so that's technically not a node equation because that's an equation where the node voltage is already defined. So now let's write the equation at node 2. So I have V2 minus V1, which is 10 over 1. And then I have V2 over 5. And then I have V2 minus V3 over 2. That's equal to 0, and it's important to put that it's equal to 0, otherwise you don't have an actual equation. So we need an equation if we're going to solve something. Node 3, I have V3 minus V2 over 2. I have V3 over 10, and I have minus 2 amps. And that's equal to 0. So pretty easy set of equations to solve. Let's come up and we'll go ahead and just illustrate, how we might solve this. This first equation, let me multiply everybody through by 10 to get a common denominator and eliminate it. So I'll have 10 V2 minus 100 plus V2 plus 5 V2 minus 5 V3, and collecting like terms, that'll give me 16 V2, got this guy, minus 5 V3 is minus 100, so that's equation 2. Equation 2. Equation 3, I have once again multiplying the entire thing through by 10. I have 5V3 minus 5V2 plus V3 minus 20 is equal to 0. Let me check that. Multiplied everything by 10. That gives me V3 here. 5 and 5. That looks good. So I have minus 5V2 plus 6V3 is equal to 20. So, how you solve this kind of depends on your personal preference. Let's copy these equations over on the next page, and I'll go ahead and work this one out for you. So we have what? Let me get rid of these. So going back, I had 16 V2 minus 5 V3. Oh, and this should have been plus. Just caught a math error. 16, 5, and 100. So 16 V2 minus 5 V3 is 100. And then the other equation, minus 5, 6, and 20. I'm sorry, I keep getting announcements that come in even though I'm supposed to be sleeping my iPad. So let me see if I can't put that on sleep. Hopefully that fixed it. We'll see. Okay, so here are the two equations and two unknowns, and so we make sure minus 5, 6, and 20. Alright, so just by method of substitution, V2 will be 100 minus 5V3, or plus 5V3 over 16. So if I now substitute that in for V2 into the second equation, I have minus 5, 100 plus 5V3 over 16 plus 6V3 is 20. So that's 500 over 16 plus 25V3 over 16 plus 6V3 is 20. So if you combine some like terms, 25 over 16, if I come to a calculator, which is somewhere, I think. I don't use the calculator on the iPad very often, so I don't pull it up super quick. I'm not seeing it right off the top of my head, so I may just leave it for you to finish from here because I don't have another calculator handy. So let's go back and look at that. So 25 over 16 plus 6 times 16 is 96. And that's 20 minus 500 over 16. So you can now solve for V3. And once you have V3, you can then substitute it into either of these equations to solve for V2. So that's just a quick illustration on method of substitution. So once again, that was the node voltage method for this particular circuit. And here are your node equations right here as far as this lecture. And that's what I want you to get out of this. Okay, now let's look at the same problem and let's define some mesh currents, and we'll use the mesh current method to do this. So let's choose I1, I2, I3. Okay, in this case, let's write, in this case, if you look at current I3, you see that this is a problem where we have a current source, this 2 amp source, on an outside branch. So I3 is actually equal to minus 2 amps. So I3 is already defined because it has a defining source equation. So we actually are only going to have 2 unknowns in this mesh current method, much like in the node voltage method. So writing around mesh 1, we have minus 10 volts plus I1 times 1 plus 2 times I2 minus, I1, erase that, 2 times I1 minus I2. Once again, very important to make this an equation and say that it's equal to 0. Okay, around mesh 2, we have 5. How did I get 2 here? That should be 5. That was this term for mesh 1. Okay, so I have 5 I2 minus I1. I have 2 I2, and I have 10 I2 minus I3, also equals 0, which kind of fell off the page there. Alright, let's check those. Minus 10, that's this voltage rise. 1 times I1, that's this voltage drop. 5 times I1 minus I2, that's this voltage drop. Coming down to the second mesh, 5 times I2 minus I1, 2I2, 10I3 minus I2. So let's rearrange those a little bit. I'll have, looking at equation 1, I'll have 6I1 minus 5I2 is equal to 10, and then equation 2, I will have 17I2, and then I'll have minus 5I1, and then I'll have minus 10I3, but I3 is minus 2 amps, so that'll change it to plus 20, if I'm doing that right. So let's check that. I had the 10I2, which was incorporated into the 17, and then I have minus 10I3. I3 is minus 2 amps. That gives me a plus 20. Okay, let's rewrite these. 6I1 minus 5I2 is equal to 10 minus 5I1 plus 17I2 is equal to minus 20. Now, just for the sake of a little bit of review, let's look at, if you wanted to put that into matrix form, how you would do that. So you basically take the coefficients, 6, 5, minus 5, and 17. That forms a square matrix, multiplying the column matrix I1 and I2, equaling the constant matrix 10 and 20. If you want to use Kramer's rule, I1 is going to be something over the determinant 6, 5, minus 5, 17. That something will take, it's a different color, the lime green. It'll take this answer column and it'll substitute it into the column of coefficients that multiplied I1. So I'll have 10, 20, 5, and 17. Okay, I2, exactly the same thing, except in that numerator, that constant column is going to replace the second column. It's going to replace the second column here instead of the first. So we'll have the original, this looks very holiday themed here, we'll have 6 and minus 5. And now this 10 and 20 here will replace the second column. Okay, so I1 will be 10 times 17 minus 5 times 20 over 6 times 17 minus 5 times 5. And I2 will be 6 times 20 minus 5 times 10 over 6 times 17 minus 5 times 5. So I'll let you plug that into your calculator, not to take up any additional video time. Alright, we'll stop this video and then we'll start up